Hello, geometry class. Before we start, I just want to kind of verify that the video is being used in the right sense. In other words, not just for pure entertainment, which I know it can be pure entertainment because it is quite enjoyable to watch, but to actually help you to learn, I'm just kind of checking in with you to make sure for example, these things should be done first. You should have done the whole review on your own. You should have, as you were doing the review, if you had to look anything up, that problem number should have been circled because there was something you needed to memorize for that. Also, then when you check it, you're circling any that are incorrect on the first time around. Then it's time for the video, and the ones that you had correct and didn't need to look up, I would still watch the video, and that is more of just the reaffirmation of what hopefully you knew because you got it right the first time. The other ones, if there's something to memorize, you should write that, memorize in red so you don't forget, if it's the triangle or whatever. And then if it's one that you had wrong, you want to really look at your work and watch what I'm doing and see where you went awry. Then, at the end of the video, you want to either try that one again on a blank piece of paper without looking again, or set it aside, right, for a little while, not do it immediately, or look in the back of the book at the review for one similar and try it again. Because just watching me do it won't mean you can do it. So just putting those out there to make sure you don't fall into the kind of the lazy mode of just watching and thinking that's enough and you've done your part. This is meant to be an aid to help you, not to be the sole answer. So that's all. We're going to have a lot of fun here because I'm also going to add a couple of problems in here that are new for you to try that actually were not on the review and wish they were. So you want to stay tuned on that. And let's just get going here. So the whole chapter is about right triangles, really. And so you need to know how to be able to analyze right triangles, deciding what information you're given, what are you trying to find, what things do I know? So you got a whole gamut of things now. You have Pythagorean theorem. A squared plus b squared equals c squared for any right triangle. That's for the lengths of sides. That doesn't have anything to do with the other two measures. You just know you have 190 and you're trying to find sides. You also have your special 45, 45, 90, where the sides are x and the hypotenuse is x root 2. So it was simplest to think if I'm given a leg, you multiply by the square root of 2 to get the hypotenuse, and if I'm given the hypotenuse, you divide by the square root of 2 on both sides, or to get the leg. And then you have to, of course, rationalize the denominator because you can never have a square root in the bottom. Another thing you've learned is the special 30, 60, 90. And that means the side across from the 30 is x. Across from the 60 is the x root 3, and the hypotenuse is 2x. So sometimes it helps if in a different color you trace this on the outside of the triangle you're working on. So I'll show you what I mean by that when we get going. And then lastly, we also, well, not lastly, but we had SOHCAHTOA, sine of an angle equals the opposite side over the hypotenuse. The cosine of an angle equals the adjacent side over the hypotenuse. The tangent of an angle equals the opposite side over the adjacent side. And then we also had the inverses. And that's where you use that if you were to find an angle. Whereas these are more used to find sides. I think that's it. So let's get started. And you may want to just put that information, well, number one, on your review, but number two, that might be purely what you want to memorize for the test. And when you get the test, you can put it at the top or on a separate sheet of paper so that you just have it in front of you to resource throughout the test and not have to worry about forgetting it. All right. So find the value of each variable expressed in the simplest radical form. Okay, I see that it tells me how to express it. It's underlined, but I'm also going to highlight it so that I don't forget that at the end. And all those highlights, I will double check, or you should double check, at the end of your test prior to turning it in. Any of the highlights, you go back and make sure that you didn't forget those. Okay? All right, so here we look at this problem. And we have to decide, which of these things, which of these resources are we going to use? Well, right away I'm noticing I got a 30, 60, 90 triangle. So my first guess is that I'm going to use the 30, 60, 90. Doesn't mean I have to. If I had two sides, any two sides, I could use Pythagorean, but I only have one side, so that's not going to work. Could I use sine, cosine, tangent? Yeah, but it's going to be harder because you're going to get an approximation. So since it says to use a simple radical form, that's kind of a clue to me that I'm going to use a 30, 60, 90. So I'm going to do what I told you to do before, which is put those variables around the edge on here, just out further in a different color so it doesn't get mixed up. So opposite the 30 is your x, so that's my x. I actually changed these to A and B so that the x's didn't get confusing. Opposite the 60 is x root 3. And the hypotenuse, which is always across from the 90-degree angle, is 2x. So you have that. You can figure out any side now. But you've got to get the x, don't you? So you've got to look for the one with the number. This is the one with the number. And I'm like, okay, that's equal to 2x. So 2x equals 30, so x is 15. I now have everything I need to get all my sides. So let's go back in now. This side is x. And this side, which they labeled as y, so I'm going to too, but I'm going to look over here now. X is 15 root 3. That's the length of that side. Just happens to be labeled y. Done. Look at the next one. We have a 30. Again, well, that has to be 60. 90. So it's going to be similar, I think. I'm going to use a different color so it doesn't go with that pink. Opposite the 30 is your x. Opposite of the 60 is x root 3. And the hypotenuse is 2x. So again, we got to figure out what x is, and I can get all those sides. Well, this worked out nice again because x is actually exactly 5. Whereas here I had to divide it to get the x. Here I'm given it. So x is 5. So this side is 5, we know. This side is 2 times 5. So that side is 10. And this side is 5 root 3. So now I just need to go, and I should have done that maybe over here too, because that was helpful. When I put the x is 15 here, and then 15 root 3 here. Write them right along the side, then you can go back in and grab the letter. A is equal to 10, and B is equal to 5 root 3. That is not the best pen in the world. Let me see if I can find a better one. Okay, going on to number 3. So again, we got multiple triangles here. So I don't see any 30s or 60s or 45s. So my first instinct is that I'm not going to use these two. Okay. might be able to still use this. I mean, we've got this odd four-sided figure here that I'm not going to be able to do anything with, but I have two triangles, so I want to analyze each of those triangles. They're both right triangles, so I can use any of this for either. This one has two variables and a side. This one has, two sides and a variable. We can use Pythagorean theorem. I have at least two of the sides, so we're going to do that. I'm going to focus in just on this triangle right here. So if I do that, which one's the hypotenuse? A. So that's the one always that is alone, the hypotenuse. So I'm going to have 8 squared plus 6 squared equals A squared. Remember, you square them first. 64 plus 36 equals A squared. Then add them. 100 equals A squared. And then square root it both sides. And I'm going to rewrite it with the A over here. Square root of 100 is 10. So we found one of the sides now. And this is 10. So I'm going to go up here and write that in. Well, look what we have now. Now we have this triangle. And we have two sides now. So we can use Pythagorean theorem again. B is, again, the hypotenuse. So that's the one that goes alone. So I have 10 squared plus 5 squared equals hypotenuse squared. 100 plus 25 equals B squared. 125 equals B squared. I'm now going to square root both sides, and I'm going to flip it so I have my variable on the left. So I have a square root of 125. I have to get it in simple radical form. These are, square root of 3 can't be broken down, but this can be, because I'm trying to think of a perfect square now. So the perfect squares are 4, 9, 16, 25, ding, 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 25 times 5. So the square root of 25 is 5, and that escapes out of the square root, but this 5 is left inside. And we're done. Okay. Again, given two triangles, given no angles, given some sides, some not sides, I'm thinking Pythagorean theorem again. So let's look here. On this triangle, I only have the one side, but on this triangle over down here, I do have two sides, so I can do Pythagorean theorem. So 5 squared plus 12 squared equals, let me slide it over so we're on the screen, A squared, that's the hypotenuse, across from the 90. 25 plus 144 equals A squared. Now I add them. 169 equals A squared. Square root both sides. And I'm going to flip it. A equals square root of 169, which is 13. Okay, so I got that side. And again, we can go over to this triangle now and do Pythagorean theorem. This is a leg, and this is a leg, and again, this is my hypotenuse. Don't get those mixed up. So I have 13 squared plus B squared equals the hypotenuse squared. So I have 169 plus B squared equals 196. I got to get the B alone, so I'm going to subtract the 169 from both sides. And I get what? 27. And I square root both. And I'm there. But I have to get it in the nice form, and I'm thinking of my perfect squares for 9, ding, ding, ding. 9 times 3 is 27, and 9 is a perfect square. So then square root of 9 can break free out of the square root, and this 3 over here is still stuck inside. All right. Okay, I'm seeing 60s and 30s. My instinct is to use 30, 60, 90s, but it's possible I may not be able to. Let's look. I have a 30. So if this is this is an isosceles triangle. Actually, it's equilateral because that's 30 and that's 30 as well. So we got an equilateral triangle. So when you draw perpendicular down the middle, it splits this into two 30s. So I do have a 30, 60, 90, and I have one side. So I'm going to focus on this triangle right here right now. Right there. And I'm going to go ahead and write those things that I said to write on there. So opposite the 30 is x. Opposite the 60 is x root 3. And the hypotenuse is 2x. So we need to figure out, what are we figuring out? So we are trying to figure out what A is, and that is the length right here. In order to do that, I need x. So I go back over here, and I know 2x is equal to 11, so I can figure out what x is now. X is 5.5. So I have all my answers now. This side down here is 5.5. Well, we knew that was 11, and now this one is 5.5 root 3. I take this exact thing, but I'm putting in 5.5 for the x. So A equals 5.5 square root of 3. So I've got that all done. And now I need to focus. This gets a little harder to see. I might rewrite this. I think I will. I'm going to rewrite that triangle right here. And I got the 60 down here. And we know this side now because we just figured it out. It's right here. 5.5 root 3. And we need to figure out this side. And this is 30. So let's put those, what do you call it? Letters around the edge. So opposite the 30, that's my x. And that is my 2x. And this is my x root 3. So slide it up. So I put those on there. I really highly recommend that in a different color so it doesn't all start to blur. And we know we want this. We want B. So if I know what x is, I've got my answer. And I got to look over here now. I have this is equal to this. What does that mean x is? I mean, maybe you can just see it, but if you can't see it, look what happens when you solve for x. It's just 5.5. And maybe you saw that right there, how it was sitting in the same position. No problem. We're all done. B is 5.5. If you needed to get the hypotenuse, you would do 2 times 5.5, 11, which is, of course, the same as that, so that makes sense. All right. Or you could, actually, now that I'm looking at this, you could have noticed that they were the same and figured out x that way. That would have been fine, too. All right, let's look at this one. We have, what do we have here? It looks like we have a square, 4 equal sides in that. So if that's a square and it's wondering what this angle is, what would it be? Right, it's going to be 45. So we know that off the bat. It has to be. If you have 4 right angles and you have 4 equal sides, it's a square. So when you draw a diagonal, it's going to split it in half. So now you got to figure out what each of the sides are. Okay, well, we're ringing the bell, are we not? 45, 45, 90. So if this is 12 and this is 45 and 45, and there's my 90. Remember, we want, this is my x root 2. So remember how we go from the hypotenuse to the legs? Divide by square root of 2. That's right. So, and that's the side I want right here, A. I'm tracing this right there. So I have 12 divided by square root of 2. Really? Really? Hello? Okay, no one was there. Sorry for the interruption. All right, square root of 2, square root of 2, and then we end up with 12 square root of 2, and what's on the bottom? Square root of 4, which is the 2. 1 and 6. My answer is 6 root 2. So where's my thing? A equals 6 root 2. Okay. Now, so that's, wow, look at all that fun work. Write each ratio. So this part should be swift and easy for you. So if you're not understanding these ratios, please, please, please ask me. Little Zevia here. All right. SOHCAHTOA. It's just ratios. That's all you're getting in this one. So literally the sine of A. Sine is opposite over hypotenuse. So you got to make sure you grab the right angle. Okay, so there's A. I need the opposite side of A. So if I go opposite, it's 21. Over the hypotenuse. Where's my hypotenuse on here? Right here. Done. Cosine of A. Cosine is adjacent over hypotenuse. So cosine of A equals, again, find that right angle, and then adjacent is touching the angle but not the hypotenuse. 20 over the hypotenuse. 29. I highly recommend you, label the hypotenuse. Okay, tangent of A is opposite over adjacent. So if we go over here, again, which angle? Make sure A, and then opposite is 21. Again, adjacent is the one that touches the angle but is not the hypotenuse. It's 20. And sine of B equals, sine is opposite over hypotenuse. I threw in a new angle, so I'm going to go up here and make sure I use that as my reference angle. And I need opposite of B, 20, over hypotenuse, 29. So isn't that interesting? The cosine of A is the same as the sine of B. And that is accurate. That is what happens. Okay, so when we go to these, again, we look at it and we got a degree. That looks like what we're trying to find. Got a side and a side. So when you're thinking about these different things that I put at the top here, I mean, yes, you have two sides, you could use this, but this helps us to find another side. So when we do this, I don't need the other side. I need an angle. Okay, so and these help you to find sides down here. So the ones that help you find angles were the inverses. That's right. So let's take a look. If I want this angle, I have to figure out which function. Am I going to use sine, cosine, or tangent? So first I need to know that. And as I said, write hypotenuse on there so that you don't get that mixed up. It's always across from the 90. What is 7 relative to this angle? That is the opposite. So this is what tells me what one to use. Which one uses opposite and hypotenuse? Opposite and hypotenuse. Sine. So sine of x, remember the degree is always there and these always go together. We never separate those. Equal opposite over hypotenuse. Now, to figure out this angle, we simply do the inverse of the ratio, and you will get x. So let's do that. So when you grab your calculator, I'm just using this one. Whoops, why did I do off? So 7 divided by 13. And now I need to go here to the sign, but I'm going to do the inverse. So I'm going to do second and sign. And it says 32.5. But before I clear the screen, I want to make sure what it said to round to. Find the value of x to the nearest tenth. Okay, so tenth is one spot after the decimal, so I'm looking at this spot. It's a 7. That makes this round up to 6, so it's 32.6 degrees. Okay, looking over here. Now I have a degree, and I have a side, and I want a side. So it's not a... I'm just going to grab this again. Where's my sheet I wrote on? So it's not a 30, it doesn't have a special angle measure, so we're not going to want to use one of those. And I'm not given 2 of the sides and getting a third, so I'm not going to use that. And I'm not trying to find an angle, so I'm not going to be using that. I need to find a side with an angle and a side, so I'm going to use these ratios. So again, here's my angle, and I need to figure out what these sides are relative to this angle. So when I go to here, what is this one? Well, first of all, where's my hypotenuse? I always say to label that first. That's right here. Across from the 90. And this one is the opposite. So which function uses opposite and hypotenuse? We just used it. It's sine again. So sine, but now we do know the angle measure. See, over here we didn't know it. Here we know it, so I'll put in there 64 is equal to the opposite over the hypotenuse. So I have to solve for x, and to solve for x, here it is dividing by 30, so we're just going to multiply by 30. That's gone, and I'm just going to put the x on the left. So then we need to, I'm going to do the sine 64 times 30. So if I were you, I got that. But here's the deal. If I were you, I wouldn't just be watching me punch this in because your calculators are also different. And I would make sure that you're getting the same answers as I am when you're punching that in. So just as extra practice. Andrew, I'm recording. Sorry about that. Okay, so when I look at this, I am going to round to the nearest tenth, but look at, when I go to here, it's a 6, so that rounds this up to 0, which rounds this up to 27. I can't just say 27, it still has to be to the nearest tenth. So I would have to say 27.0. You guys are advanced enough now that you can get those right. Given the lengths of the triangle, identify it as acute, right, or obtuse. I should have highlighted this up here just to make sure. Oops, I didn't show you. Hello, I'm trying to move it. There it is. Should have done that. And here, these are my choices, just to make sure I don't do a bunch of work and then never actually put the answer. So you're basically, you know that a hypotenuse is always the longest side, right? So we have to just check using Pythagorean theorem. So for these, you're going to use a squared plus b squared equals c squared. Remember, this one is always your biggest because it's a hypotenuse. All right. So I'm going to look at my 3 numbers, evaluate my biggest. Here it is. So that's the one that's alone. So I need to take the 2 smaller ones, and I'm putting a box here because I need to figure out what's going to go in that box. A greater than sign, a less than sign, or an equal sign. I got to see. I don't know. I'm just setting it up. So 12 squared is 144, and 34 squared is 1156, and 37 squared is 1369. And keep the box. This is just a way I do it to keep things real clear. I'm going to add up that left side. $1,300. and this side is 1369. So now you can evaluate. What's your sign going to look like? Obviously that's bigger. So my sign is that. Now, it's a less than. So which one does that mean this is? This you also have to know for the test. Less than is obtuse, kind of counterintuitive. Okay, so less than is obtuse. Put that over there. I'm sounding like the guy from Khan Academy, repeating myself 3 times at every sentence. Repeating myself at all times with every sentence. All right, so then we look at this one. Which one's the biggest? 13. Okay, repeat. 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. 169. Oh, darn it, darn it, darn it. I fall into my... Just start cruising. I don't want this in there yet. I don't know that's equal. Get rid of it. Thank you, Mr. Whiteout. I love that stuff. Because you have to decide what goes in there. And in this case, it is indeed equal. And what kind of triangle do we have if it's equal? We have a right triangle. All right, next. 28 is my biggest. 20 squared plus 21 squared box 28 squared. 20 squared is 400. 21 squared is 441. And 28 squared. 784. And add these together, we get 841. 784. Now evaluate. What sign goes in here? Greater than. And my greater than is what? Acute. Opposite of kind of what you would think. Another thing you have to know. Ding, ding, ding. Make sure you know it. So as we've been going along here, you have hopefully been taking good notes because we have this, which is fantastic information. And now we can add that to it. So we're figuring out important information for the studious person to study. Why is that recording? All right. A fire ranger stands at an observation window 70 feet above ground. Okay, so first you have to figure out where they're standing. Where's the person? Right. Let's just put that little guy up there. Come on, little mister. You go up there. All right. Oh, whoopsie. It's a she. Little Mrs. She sees a fire in the distance. Ah! Ah! There's fire! Okay. She calms herself down. She takes a reading of the angle of depression. So the angle of depression is down, right? That angle right there. And finds it to be 24 degrees. To the nearest, highlighter. Hold on, fire, I have to highlight this. To the nearest 1/10 of a foot, how far away from the base of the tower is the fire? Hopefully it's not expanding while we calculate this. So, question, how do we solve this? Well, number one, there's a right angle here. So if we know that's 24 degrees, we know this angle measure. What would that be? 90 minus 24, 66 degrees. Wait. So I have a right triangle, I have a side, I have an angle, and I need another side. We can again go right back up to this type of a problem. Okay? So I have to figure out what I have. I have this angle. I'm not going to use that one. That's outside the triangle. That's not helpful to me. And this side is, wait, where's my hypotenuse? Because that's the right angle of this triangle, correct? And this is the right angle up here, but that's not the triangle in play. This one is. And here's my right angle, so this is my hypotenuse. So what do I have? I have the side adjacent, and I have the opposite. And I have the adjacent. So that's going to be tangent. TOA. So tangent of the degree, 66, is equal to the opposite side over the adjacent side. And now we just need to solve by multiplying by 70. X is equal to 70 times tangent of 66. Remember, these go together, never to be separated. So I'm going to do 66 tangent times 70 equals. Now, before I erase that, I'm going to look and see what was it, nearest tenth of a foot. So it's tenth. So here's my tenths place. I look after it's a 2. That doesn't do anything, so it's 157.2. Now you yell, all right, it's clear. It's 157.2 feet away from you down there. Go put the fire out. And we all live happily ever after. All right, sketch a vector 30 degrees east of south. First thing you do on these, class, put your north, south, east, west. Remember, west and east spell we. And north is always up and south is down. So always put those on there. Just, let's go over here and do it right away. North, south, we. Okay. Now, 30 degrees east of south. So you want to go to this first. You want to go to south. Okay, here's south. I want to go 30 degrees east of it. Well, east is this direction. So my vector is going to go 30 degrees like that. So I need to get my protractor out. Line this up. And, okay, now I'm off the paper. That's not good. Probably should write on the kitchen table. Okay, let's slide that down. Okay, so there we go, 30 degrees. So I'm looking, here's 90. And I'm going 30, 10, 20, 30. So right here. And I'm going to draw. And when it's east of south, so I put my arrow pointing the direction it's going. It's going east, and I write in my degree measure, 30 degrees. Okay, try another one. 40 degrees north of east. Okay, so you go to the east. Now I'm going 40 degrees north of that. So I'm going to be going above it. So again, I go up here. Here's my, I hope you can't see. Sorry about the reflection. Okay, so here's 0, so 10, 20, 30, 40. Connect it with my origin. And again, go the direction that you are. So we're going north. So my arrow is curved that way. And then I write the degree measure in there. Need any help with protractors? Please let me know. Oopsie, whoa. Okay. More with vectors. So I was trying to write them because they all kind of fell off. But those are my 3 vectors. And then it says to find the magnitude of vector A. So let's first of all write what that is down here because it's right here. So I don't mix it up. And remember, that's kind of like a coordinate. That means that on a coordinate plane, if you were starting here, it went -4, whoops, wrong way, -4, and then -2. So it went -4 and -2. So what you really can do, and you're trying to find the magnitude, so you're trying to really find this length right here. So you can use the distance formula of 2 points if you wanted. You could use the distance formula between 0, 0 and -4, -2. Or I prefer myself to just use Pythagorean theorem because you have a right angle here. So you literally would use those 2 points in Pythagorean theorem. And you just have to be careful because remember, when you substitute negatives in and then you square them, what happens? It's always positive. So we got 16 plus 4 equals c squared, 20 plus c squared, square root. So c is equal to the square root of 20. And then I got to get it in, it's not written here, but you always have to put it in simple radical form. So I'm going to think about what that can break down into. Perfect squares again. 4, I hit it right away. 4 times 5 is 20. Square root of 4 is 2. So that breaks out. The 5 stays in. Now we have to find the magnitude of b. So b is right here. I'll put that down so I don't make a mistake. Double check. Did I grab the b? Yep, I did. So again, we can plot it on here if we wanted, -1, 4, but what's going to end up happening is you'll have another right triangle, and you can use Pythagorean theorem again. So lots of practice. If you have any trouble solving Pythagorean theorem, it is the time to ask now. That does not break down anymore, so that is it. Then it says to add the 2 vectors. I want to point out that that is called the resultant. So if I were to, I could either have said do this, or I could have said find the resultant. They both mean the same thing. And you need to know that. When I use that term resultant, that means you're adding, okay? So that might be another thing you star on your note sheet here to study. So A, I'm going to just put them here. A is -4, -2, plus C, 5, 6. And it's literally as easy as adding the x-coordinate part. -4 plus 5 is 1, and adding the y's. -2 plus 6 is 4. And making sure you don't make silly mistakes, okay? Find the resultant again, B. C. I'm going to double check to make sure I didn't copy anything wrong, always being meticulous on a test. Adding my x's and adding my y's. And that is all she wrote for that. So what is this called again? The resultant. Okay. No, that's not Rand. That's Rawl. Excuse me. Rawl. Rawl is 75 feet from the world's tallest totem pole in Alert Bay, Canada. I guess you have to be alert when you're there. It is 173 feet tall. Okay, so let's put a nice pole. 173 feet tall. And then let's see, where is he? Rawl is 75 feet from the pole. Okay. This little dude is there. if Rawls' eyes are 5 feet from the ground. Oh, so this is 5. He's up here. His little eyes. What is the angle of elevation for his line of sight to the top of the pole? But remember what angle of elevation is. It's from a horizontal. So if this is where his eyes are, this is the angle of elevation. So I can write this number right here. It's the same thing. And now I need to focus in because this is the triangle I'm using. Question is this still 173? I don't think so, because that included this little 5 here, didn't it? So 173 minus 5 would be 168. Now I have, and it wanted to find the angle of elevation, so we wanted this degree. So there is my information. I'm going to highlight this, because those are the things I need. I can't let these other things trip me up. I don't need to do anything else with the 5 now. I took care of the 5 right here and got my new height of the angle of the triangle. This is still a right angle, and so I need to figure out which, if I'm using so, ka, or toa, because I have an angle I need. So I'm going to need to use an inverse. But what do I have? This is, where's the hypotenuse? It's right here. And this is the opposite. And this is the adjacent. So I'm going to use tangent. So tangent of x is equal to the opposite, 168, over the adjacent, which is 75. Again, when I need the angle measure, I'm going to use the inverse of the fraction. So let's go in here. I'm going to divide first. And I'm going to push 168 divided by 75 equal. So I get that together. Now do the inverse, which is above there. So second tan. And what was the round? Ooh, I didn't have that underlined in here. Round to the nearest tenth. Highlight it. Okay, round to the nearest tenth. So when I do that, I look in here and go, okay, that's a 9. Afterwards a 4, so that doesn't change that. So it's 65.9 degrees. 24 is so much fun that I have labeled this a challenge problem, where you get a grand prize if you figure it out. So show me work if you get this. No, I won't have one like this on the test. So it's not going to harm you not to have this explained right here now. But I would like you to see if you can figure this out. You get the Grand Poobah prize if you get this. That's right. I don't know what that is, but it's going to be pretty darn good. Maybe. Hopefully. Okay. What is the difference between sine x and the inverse? Well, we talked about it at the beginning. So, and that's all I'm looking for here. What is the difference between these? You use, I need to put an equal there. What do you use this to find? You use to find angles in a right triangle. And this you use to find sides in a right triangle. That's it. That's as simple as I want it to be. Lastly, write the coordinates for 3 vectors with the same magnitude. Okay, so I want 3 more of these. I want 1, 2, and 3. And I want you to get the same magnitude. Now let's recall what magnitude was. magnitude was when we took this coordinate and we got the magnitude. So I want you to tell me 3 other ones with the same exact thing where I'll get the exact same magnitude. Well, knowing what we know about this, would it matter if this was 4 and 2? No. Would it have mattered if this was -4 and +2? No. How about 4 and -2? No. So that's really all you need to do there, because when you square them, it doesn't matter the sign. So you can do all the combinations. So here they're both positive. Here they're both negative. Here the first one is negative, and here the second one is negative. And you are done, except that it says, explain thy answer. So you can write something like, using Pythagorean theorem, when you square a positive or a negative number, you will get the same answer. So all 4 combinations will work to give the same magnitude. Okay, I got one more thing. Don't hang up yet. Where am I here? I want to ask you a question. I want to know, if I gave you this and this, and I told you those are 2 sides on a right triangle, can you tell me what the third side would be to form a Pythagorean triple? What is the third side? So I'd like you to pause this. I'd like you to try it and then push play again. All right. So let's see here. Oh, well, here's the reality. Either this is going to be this on a right triangle. Do you agree? Where this hypotenuse has to always be the biggest. So this would never be in the hypotenuse spot because that's bigger than that. Or you would have to have this. Right? Or one of these, actually. I'm just going to just get rid of that for a second. So your empty spot, the number we're trying to find, either has to be one of these two, like this, or it has to be the hypotenuse. So you literally try it. So if I grab this, now watch this. I'm going to literally do this first one first. 16 squared plus 65 squared equals. So that's 44081. So if I take the square root of that, and it works, and it comes out even, I found my answer. So I'm going to push the square root button here. Ooh, that is not a whole number. That one's not going to work. Let's try the other one. I'm trying to get this so you don't see the reflection of that light. Okay, so let's try this one. Now, what we're essentially doing here, right, is we're taking the biggest one squared, We're going to subtract this one. Push equal. And again, do the square root. Oh, ding, ding, ding. Found it. Now, FYI, you can do all the work. So if that, but I'm not going to actually require you to on Arrow. I just want you to try to play around and see if you can figure it out. But if you didn't follow this, then do the work. Do every step, right? So 16 squared be 256 plus 65 squared is 4225. And then you subtract, right, the 256 from both sides. I can just put b squared in there, I guess. B squared equals minus 256 equals 2969 square root 63. And when you get that whole number, you've found the winner. When it's a decimal that goes forever, you have not found the winner. Okay, try another one. I'm going to give you 15 and 113. Pause it, try it, and see if you can get the other number for the Pythagorean triple. All right, so again, this is smaller than this. This will never be the hypotenuse. So my options are either it's this or it's this. It's one of those two. The letter I'm picking here is irrelevant, right? So, now this is 225. That's 113 squared. 12 cents again. So 225. I mean, the numbers are the same, right? But the difference is here we're adding them. So I'm going to add, sorry about this calculator issue I'm having, add 225. I do the square root now. It comes out to like crazy land. So this is not it. Now let's try this option. Well, because I need a whole. So I'm going to now subtract the 225. See, so one of them you're adding in, one of them you're subtracting. 12769 minus 225. Now we do the square root again and see if this one works. Hopefully it does. Boom. 112 is your answer. Okay, you're going to do one more for good measure. And then I'm going to give you my recommendation for a Lenten book, which I know you can't wait for. It's 65 and 72. Find the third number. Pause it, do it, and then start up again. All right, so it's either that or it's both of them together on the same side. So, I'm just doing them both at the same time here. Okay, so I'm going to do this one first where you add them. Actually, that's all right. I can do this one. 4225 minus 4225. Square root. Let's see, is this the winner chicken dinner? No siree. This one better be. I made a mistake, right? 4225 plus 5184 equals. Now square root and ready. Yay! And we have a winner. Okay, awesome. If you followed all that, you should be ready for the test. Don't forget to study the things that we went over. So here's my recommendation for Lent. It's called In Conversation with God by Francis Fernandez. If you see here, I have been using this for multiple years, and my kids were little because there's scribbles all throughout it. And the interesting thing is I've never made it through this book. So I've been trying to get through this book since my kids were little. And if you notice, it starts off with lots of highlights, right? All these really good things highlighted. Oh, yeah, great. Yeah, look at it. I keep going. I'm even, oh, wow, third week of Easter. Yes. Meow. No highlights. Oh, but we got some kids writing back there. So God tells us to try and try again. So I am going to try again to get through this book this Lent and Eastertide. And I'll let you know if I do it. All right. We'll talk to you soon. Bye, class.